Hi, I'm Emma. I'm a senior at Swarthmore College, and I'm going to be discussing some different ways of conveying location data through mapping at a level appropriate, maybe for a student in maybe a second semester applied statistics course. And we're going to be using volcano data from the Global Volcanism program. There's two data sets. One has every recorded volcano and one has every recorded eruption, and this goes back thousands of years. So combined, you have data about latitude and longitude of volcanoes, names of volcanoes, magnitude of eruptions, nearby population. And this is a very up-to-date data set that is regularly being updated. So with this data set, there are lots of different questions you could ask and seek to answer. So some questions might be like, are volcanic eruptions increasing over time? And some might be more like, where do volcanoes erupt? What volcanoes are near me? Should I be worried? And so like the type of visualization that will be good to answer these questions will vary based on what the question is. But if you want to answer a question that it would be appropriate to map the data in order to answer the question, then we can explore some different ways of mapping that. And we always want to think when we're making a visualization, what exactly is our goal? What information do we want to convey? And is the visualization we're making the best way of conveying that information? So we might start out with a simple map. This is really easy to make. It's made with ggplot2, dplyr for data wrangling, and maps for the actual map. So this is literally just a dot for each volcanic eruption. So we want to think back to what our question was. So is it, where have volcanoes erupted? Or is our question more nuanced than this? And this graph doesn't really answer the question. So we're going to think about how can we change this map to more clearly present the desired information, or what additions can we make to it to really answer the question that we want to answer. So we have a lot of tools sort of in our toolbox here to alter this map. And one of them is changing the color of the dot. In this example, we've changed it to reflect the average VI, which is a measure of magnitude of eruption. So with a visualization like this, we want to think about whether this map is really an effective way of conveying the data. And if not, what tools do we have to improve it? So for example, if the color is not really appropriately conveying what we want to convey, do we have other color schemes that might make the data more clear? Or could we vary like the radius of the dot instead of the color of the dot? And considering these tools, what other questions might we be able to answer? Or have we generated any new questions about the data? Are we curious about new things we didn't realize we could ask about before? And are there questions we want to answer that we can't answer with our current tools? And so if you have questions that you can't answer with this simple tool, then an interactive map might be a really useful tool. So you can make an interactive map. This is a little more complicated than making something with ggplot. This was created with our Shiny, Leaflet for mapping, and dplyr again for data wrangling. So we want to think about, what is interactivity adding? It might be useful if you have a large variety of questions you want to answer, or if you're creating a tool for someone other than yourself who might have questions that you might not be able to anticipate. And this map is live at this link if you want to access that. But if you're in a situation where you're creating a tool or a visualization for someone other than yourself, an interactive map can be a really good idea because you can alter the variables. You can allow the user to alter the variables themselves. So for example, in this visualization, the circle size and circle color can be changed by the user to reflect different variables. So now that we've made a couple of different visualizations, we want to consider what was our purpose? So were we really just curious about a simple question that we wanted to satisfy our own curiosity? Or were we creating something for someone else? And if we're creating something for another person, we really need to consider what our audience is curious about. So if our audience wants to know about only volcanoes that have erupted since 1980, we need to make sure that our visualization only includes volcanoes that have erupted since 1980. Also, we want to consider what type of visualization is most useful for our purposes. So interactivity can be really cool, but sometimes it can add unnecessary complexity to the project. So static maps with ggplot2 are really easy to make, they're really easy to share and display, and they might be the best option for your purpose. Interactive maps with RShiny are really cool. They can answer a lot more questions than static maps might be able to, but they're much harder to create, and sometimes they're hard to share and embed in websites. However, there are many resources available to make this process easier. If these tools that we've talked about aren't enough to answer your questions or create a visualization that's complex enough for your purposes, there are lots of other resources available too. So for example, if you want to make a static map, there are many other mapping packages, including packages like OpenStreetMap that might allow for easier zoom or more detailed maps. There are also much more code-heavy solutions that might involve, that might require having a more rigorous computer science background, but also allow for many more options. So for example, this is the beginning of a visualization of volcanic eruptions using JavaScript and D3.js. So as you can see, D3.js allows for visualizations to be really easily embedded within a website, and you can do things like have a globe instead of just a flat projection, which might remove some bias of a flat image instead of the full globe. And thank you so much to the Global Volcanism Program for providing easy access to this data, and many thanks to Dr. Kelly McConville for helping me throughout this process. And please feel free to contact me if you want any code or if you have any questions. My email is here. Thank you.